Hello guys, my name is Dimitris from Structural Details, and in this video I will guide you through this easy step-by-step process on how to create fully parametric families. In this example we will create this nice looking kids activities small table, and we will include every aspect of the table as a parameter: the height of the table, length and width, the tabletop thickness, the legs diameter, offset of the legs from the sides, and as well as creating parameters for the materials to be used, the tabletop material and the legs material. It's essential to create parametric families whenever possible, and we will most definitely increase your efficiency, your productivity, and give you a lot of flexibility when using this family with your projects. Thank you for watching, and let's start creating a first fully parametric family together. To start with, we're gonna open a new Revit family using the generic model template. Now for this video we are assuming that you have some basic knowledge of Revit's interface and a few basic commands: extrude, inserting dimensions, and so on. We are currently in the plan view, looking from the top down, and the first thing we need to do is create reference planes, reference lines, which will be our reference for the tabletop. I'm just drawing the reference planes randomly, and we'll see why in a second. Next thing we want to do is insert some dimensions from the left reference plane to the center point to the right reference plane, and then click equal distance from the vertical axis. What this does, it will ensure that these two vertical reference planes always have an equal distance from our center point vertical axis. And we will do the same for the horizontal reference planes. Click equal. So as you can see now, if we move one of the reference planes, they both move together, always keeping an equal distance from the vertical axis. The same happens with the horizontal as well. Now we will add a dimension. This will be our length dimension for the table, and a vertical dimension which will be our width. Basically what we did here, we have added 4 reference planes that will be our guide for the tabletop, and these reference planes are always at an equal distance from our model center point. Currently the 2 dimensions we've added are static dimensions, and what we want to do is turn them into actual parameters, one for the length and one for the width. There's 2 methods of doing that. One is by simply selecting the actual dimension, and where it says label dimension, since we haven't got any parameters assigned yet, we need to create one. Just click on the create parameter button, and first thing we need to give it a name. We will name it length, and it's a length parameter dimensions. Okay, we have just created our first parameter, and if you want to see it, it's by clicking here on the family types icon in the toolbar. Here it is. Length is our first parameter, and currently it stands at 1720 millimeters. We can simply change it now to 1500 millimeters, and as soon as I hit apply, you will see how the 2 reference planes will automatically adjust. Apply. There you go. Next method to assign a parameter, we can do it for the width of the table. Again, open the family types. We only have the length parameter and we need to add one more. I will click here this new parameter icon, new parameter. Again, give it a name width. Type of parameter length, that's the correct type. We can also choose an integer, a text, an angle, area, and so on. We want length and it's a dimension. Click OK. Our second parameter is called width and currently it has a value of 0. I will go in and give it a number of 1000 millimeters. Apply. Now we need to tell the program that the new parameter we just created needs to be associated with this dimension. Just choose the dimension and from the same drop down we now have the width. Click on it. There, it's assigned. To change the value of the parameter, either we can change it from the family types window, change it to 800, or click on the actual parameter there you go, and change it to 900. So two methods to assign parameters. First, select the dimension and create a parameter from the button available, or visit the family types window, create the parameter, and then come back and associate that parameter with a specific dimension. What we have actually accomplished here is we have created a parameter with the name length, which holds a specific value, in this case 1500 millimeters, and it controls the distance between those two reference lines, which are also at an equal distance from the center point. And the same stands for the width parameter. Width parameter has a value of, currently has a value of 900 millimeters. It controls the distance between these two reference planes, which are at an equal distance from the horizontal axis. Next thing we want to do is create our tabletop. For this, I'm going to use the extrusion command, create extrusion, and then we will use the pick lines tool and lock onto the lines we are going to choose. So we come into our plan view and pick the lines we want to use as the perimeter of the tabletop. We're using the reference lines we've created, and you see the lock icon that it automatically locks these lines together with the reference plane. This means that when the reference planes move, the actual model will move with it. And using the trim tool, trim the edges and apply. I will change it into a shaded view. Here you go. We have let's see it in 3D. We have a extruded model and it's locked on the 4 reference planes. If we change our length parameter to 1200, this will change the actual size of the extrusion. Now, regarding the height of this extrusion, because currently is way too thick, what we should do is add another reference plane which will reference the actual height of the table. This is my table height. I will enter a dimension for it, and I will assign a parameter to this dimension and name it height. Okay. Change the parameter to 600. And now our extrusion needs to be associated with the top of this reference plane as the tabletop, but we also need the thickness of the tabletop. So let's create another reference plane here, add a dimension that will act as our tabletop thickness, and name this tabletop thickness. 74 millimeters is very big. I'm gonna change it to 20 millimeters. And what we need to do is lock this extrusion onto the two reference planes by clicking and dragging the top of the extrusion to the top reference plane. Release the mouse. It will give me the option to lock the surface onto the reference plane, which I will do, and the same for the bottom surface of the extrusion, and lock. So currently we have 4 parameters: one for the height, one for the length, for the width, and the last one is for the tabletop thickness. Let's have a look at our model in 3D, and let's test our parameters to make sure that they are working correctly. If I change the height and click apply, we should see this extrusion move upwards. Works fine. The width of the model, change it to 600. Yes. And the length, I'm going to change it to 800. Very nice. Now for the table thickness, currently is at 20 millimeters. Let's make it 30 and see if it makes it thicker. Okay. We can also see this in the front elevation view. Changing, let me make this smaller. Changing the height to 600 should move everything down. As you can see, the second reference plane, which is the reference plane for the thickness, it moves together with the top one, which is referenced as height. The reason is because the top reference plane is associated with the height, and by changing the height, this reference plane moves along with it, and the second reference plane is associated with the height of the table with this parameter, which is set to 30. So the program needs to keep always this distance equal to 30. Wherever we move the height, the other reference plane will move together with it. One more time, let's see how our parameters work, and then we will move on to creating the legs for the table. Up to now, we have created dimensional parameters. The parameters are controlling the reference planes. So when we change the value of the parameter, this moves the reference planes, and the extrusion itself is locked onto the reference planes, not the parameters. The extrusion is locked onto the reference planes. Because the reference planes move, the extrusion moves with it. Moving on, we now need to create our table legs, and to do that we need to add 4 more reference planes, and those will be our legs center lines, center of the legs. Again, I'm placing them randomly, and then we will add dimensions and create those into parameters as well. So I'm adding dimensions for the center of each leg offset from the edge of the table. Okay, and select one of these dimensions, create parameter and call it legs offset. We want this offset, let's make it 75 millimeters. And then for the other three dimensions, again select the dimension, drop down since you already have the parameter we want ready, and select the legs offset parameter. You see how the reference plane moved to lock into the 75 millimeter value. Select both of these, holding down the control key, drop down legs offset. These are our center lines for the 4 legs of the table. If the offset is changed, let's make it 90 to see how the 4 reference planes move together. Apply, and they work nicely. Okay. Again, when creating parametric families, if there is the slightest hint that at any point a user might want to change an attribute of your family, we should change that into a parametric value in order to make it easier to make any necessary changes in the future. Now let's move on to add our legs. Those will be circular legs, round legs, and again I'm going to use the extrusion method. Now we will select the circle, draw method, select our center point, and again I'm not worrying about the radius of the circle, we will set this later on. Drawing the 4 circles for the legs. They are not similar at this point, and before we execute the extrusion command, now I'm going to add a diameter dimension just by selecting the 4 circles, and then we will name those dimensions into a parameter. Select the dimension, click on the create parameter and name it legs diameter. Select the other 3 dimensions holding down the control key to make a multiple selection, holding down, changing the dimension into a parameter legs diameter. Let's change the scale. There you go. And now I can finish my extrusion. Going into the front view, these are my legs. What we need to do is lock them onto the lower surface of the tabletop and at the reference level. To do that, just drag the extrusion to the desired reference plane, release the mouse and lock. Do this for the top part, release the mouse and lock. This is the legs for the table. Let's have a look in 3D. Okay, let's test again. It's wise to keep testing your parameters as you move on, because if by any reason there's an error at one of your design parameters and locking together one with the other with the reference planes, if you move on too far along, you might have trouble finding out where the problem actually is. If you keep testing every step of the way, then you know that something is not working right and you can fix it easily. So let's test the legs diameters. Let's make them 80. We should see the legs get thicker as expected. Changing the height of the table, make sure that the legs move together with the tabletop. Make it 900, and move up, make it 400. Okay. Looking at our 3D model, we realized that this is a kid's table and it's not wise to have sharp edges for the tabletop. And what we need to do is edit this extruded surface and change its perimeter with a nice rounded edge. How to edit the already extruded surface? Just double click on the actual surface, and now we are in the edit mode. These are the 4 lines we created at the beginning. It's best to look at it in the plan view, top view. And what I need to do is add an arc at each corner, at 45 degrees, associate also with the legs center line, and then trim. So what I'm basically doing, I am changing the perimeter of the extruded surface. There you go. Click OK and go back and see it. There you go. Nice rounded edges. Our next parameter that we need to add is actually the materials parameter. In this example, we will create 2 material parameters, one for the tabletop and one for the legs. How to do that? Select the tabletop, and here where it says in the properties panel, where it says materials, on the right there's a small button, associate family parameter. It is asking us to choose one of the available parameters. Since we don't have any material parameters yet, we need to create one and give it a name, tabletop material. Okay, and we do the same with the legs. Select the legs, material, click the parameter icon and add a new parameter, name it legs material. Okay, if we open our family types window, we can now see the 2 new material parameters available to us to change, together with all the other parameters. So let's go ahead and create, for the legs, I'm gonna create a blue plastic material, rename it into blue plastic, open our material library, plastic, let's find a blue color, glossy matte. Okay, apply. Do the same procedure for the tabletop material. Let's name it red plastic. Materials library, search for plastic and acrylic red. Apply. Okay. In order for us to be able to see the selection of the materials, we need to change our view style and select the realistic view style. Maybe I should go and change the tabletop. Since it's a parametric material, I can easily change the tabletop. Let's find another material. This was a little bit see-through, burnt red. This must be okay. And so we have our finished product ready to be used. Plus there's one more last step we need to do, which we'll go through it right now. As an optional last step in creating our parametric family is to create specific versions of this table so we can have them ready in our project. For instance, if this is an actual product from a catalog and we know it comes in 3 sizes, it's wise, it's not required, but it's proper to create those 3 variations of the table so we have them ready in our project, and there will be no need when designing to go and reference and find what size of this product is available so we can design it. In order to do that, we open again our family types, and you can see now where it says type name currently is empty because there are no family types created yet. So what we need to do is create a new type, give it a name. I will name it table 1 with dimensions let's say 600 by 500 millimeters and 400 millimeter height. It's just a name to distinguish it from other family types, and height we want it to be 400 millimeters, the length we want it to be 600, and the width 500. And remember to click apply. So this is our table 1 type, which is available to be purchased. Creating a new type, I will name it table 2 and give it dimensions 500 by 400 millimeters and 350 millimeters height. This is just an example. Changing the height 300, the length to 500, and the width to 400. We can also change the legs if we want, make them a little bit different. That's our smaller variation of a table. Remember to click apply. And the third family type, let's create a third one, table 3. Let's make this one bigger. Let's make it 900 by 700 millimeters and give it a height of 600 millimeters height. Height 600, length 900, and width 700. Click apply. If you open this drop down selection, you can see the 3 family types we have created, and this brings us to the end of our tutorial on creating parametric families. As a last step, I will show you how to import a family into an actual project and change the family type between the available family types we created. In order for us to be able to load this family into any project, we first need to save our family. Save as family. Just gonna go ahead and save it into the desktop. I will name it table parametric. I will close the tabs and keep only one open so we can use it and load it into our project. And now I'm gonna create a new empty project, new project, select the architectural template. This will bring us again into the plan view of the project, and to load our family, go back into our family, select load into project or load into project and close. You don't need it anymore, so we can close it. And once it's loaded, before I click at any location, you can see that we have a table parametric. This is the name we gave to our family, and it's currently selecting the table 1 type. We can open the drop down and select any of the 3 types we created. Let's stick with the first version and place it somewhere in our model. Going to 3D, let me hide these levels, we don't need them for our case. Here is our table, turn the shadows on and the realistic visual style. This is our table. Let's make a copy of this, move it next to it, and I'm going to select the next family type we created. You see, it's the same family. We have 2 tables belonging to the same family, but they have a different family type. And copy this again for our third family type. Select the drop down, table 3. Let's see how easy it is for us now that the family is parametric, how easy it is to change its parameters and change the size. Selected the family type 1, click edit type, and either we can change this family type by simply changing any of the parameters, 500, keep it back, or if you want to keep this family type and create a 4th one, click duplicate, name it table 4, let's do it 500 by 400 millimeters and keep the same height. (500 by 400) and OK. So this is actually now our 4th family type. We've created another one inside our project. If you want to add another instance of this family, just click architecture, component, select the desired version of this family. Let's do type 1 again and place it anywhere in our model. So this is it. Thank you for watching, and I hope you can now create your own fully parametric families to use with your projects. Increase efficiency, save time, increase productivity. Thanks again.